The sun rises every morning and sets every evening. This is something every sentient being on this planet knows. But for an almost insignificant number of people, this is a problem for the way they view the world. These people actually believe the sun doesn't set. They think it's always in the sky. That may be hard to believe. Since the sun is so bright, how can it possibly be in the sky and not be visible? They have devised some imaginative ways of solving this apparently unsurmountable problem. I have made this video to compare one person's model with the scientifically accepted model, and then to compare these two models with what we observe when the sun rises and see which one is most likely. It's not going to be hard. If you have ever watched a mountain get brighter as the sun rises on a clear day, you will have noticed that at some point, some part of the mountain is lit by the sun and the other part is in shadow. There is a border between the bright part and the dim part, and the brighter the sun and clearer the sky, the more distinct this line appears. On Mount Everest, for instance, because the atmosphere is so clear, the line is easily visible, but on Pine Mountain, the atmosphere is dense and filled with more particles and water vapor, so although it is easy to see the top bright half and the dim lower half, the line is less distinct. Kyle Adams has produced a video that purports to explain how the sun can still be in the sky, yet the light move up or down a mountain. In his model, he has the light from the sun curve so that it moves across the ground as the sun rises, or as he would say, as the sun gets closer to the mountain. Remember, it's always up in the sky, but cannot always be seen. He also postulates that the light from the sun is reflected by distinct layers in the atmosphere. He describes the dull yellow lines in his diagram as primary reflected light, and the bright yellow lines as direct light. The result of this curving and reflection is that as the sun rises, or as he would say moves closer, so the duller primary reflected light moves down the mountain, followed by a brighter direct light which moves up. This results in two transition lines, one moving down the mountain and another moving up, as he explains in the following conversation. Question. So a very short time later, in the morning, the line has moved down the mountain and is in this approximate position, but not straight, with the brighter primary reflected light illuminating more of the mountain. Answer by Kyle, yes, as you see in your yellow mountain video. Question. Now, how about when the bright yellow line hits the base of the mountain? Does this create a second transition line? Is this a second transition line? Answer, yes, but be reminded that it is a gradient. Question, not a line? Answer by Kyle, it is a soft edge. A soft edge is a line. Then, using a photograph he took showing the top part of Pine Mountain in sunlight and the bottom part in shadow, where I drew in the transition line in red, he confirms that he saw this line moving up. I ask, so this red line on the mountain moves up? If so, then you are right. Answer, you finally admit it, thank you. Question, how can I tell it's moving up on a still picture? I only have your word that you say the red line I drew is moving up. Why should I believe you? Answer, because it is brighter where I am standing. As I keep saying, go observe it for yourself. I have observed it many times. Now, this diagram explains the scientifically accepted model, showing the sun at first below the horizon at time 7:31, and light scattering off of the particles in the atmosphere, illuminating the whole mountain with approximately 400 lux, lux being a standard measure of brightness. Then, as the sun rises over the horizon, so the top of the mountain is illuminated by gradually increasing light intensity, starting at about 1000 lux and increasing to about 1600 lux when the mountain is fully illuminated. As more of the sun rises, so more of this light is scattered by the atmosphere, leading to the lower part of the mountain also increasing in brightness from about 400 lux to 550 lux. These lux values depend entirely on the clarity of the atmosphere, not any imaginary distinct layers, as in Kyle's diagram. As the example of Mount Everest shown earlier demonstrates, the clearer the atmosphere, the brighter the top and the less light being reflected towards the bottom part of the mountain, resulting in a much more distinct transition line. Now the question is, which of these two models match the following video of the sun rising over Pine Mountain? Do we see two transition lines, one moving down, then another moving up? You decide.